Hi everyone. So today we'll be talking about the wood column template. So to make one, we go into wood columns. So you can build a wood column template for per ASD or LRFD load combinations. And here we'll just use a generic concentrically loaded column. And we'll go through the assumptions, inputs, references, as well as designing and reading our outputs. So when you open it up, you can see the assumptions that are listed. And so it's of note that we don't currently consider prismatic or tapered and notched columns. And for impact live loads, we conservatively assume wood to be treated. And some other information about in built-up columns, the plies X and Y direction are all consistent, even when the width becomes longer than the depth. So these are our key assumptions. And I'll go through inputting the geometry for a wood column first. So we can list the height here, and which has been at default set at 12. And if you want multiple supports, we can actually add supports here, such as a support at midpoint can be added here. And in this case, we have a pinned roller column, which is supported at the mid height and at the top. So we can see the free body diagram here. And in order to add loads, so by default, we add actual loads in the actual direction. Actual loads as well, actual lateral as well as momental loads can be added on the in this portion of the inputs. And we'll see that this only applies for major axis loading. So these are x-axis loading. And we can also add eccentricity here. So we can add eccentricity to all of our loads. For example, if we have 1 inch of eccentricity, it's applied to all loads, and then that can be overwritten here. So if most of your loads are applied at a certain eccentricity, but one of them isn't, that can be overwritten. We can define to include self-weight of the member or not. So usually I like to leave this on, since as the member gets heavier, it'll consider that automatically. And then in this collapse section, we can add weak axis loads. So weak axis loads also includes eccentricity in the weak axis direction. And we can see that if we consider a 1 inch bending eccentricity for bending about y-axis, even though we don't have loads, we have y bending based on the actual loads, the general actual loads coming down the column. So do be careful when you're considering if there's eccentricity or not. But in this case, it's just consider one-axis bending and compression. And then other inputs that we can consider are if the member is repeating or non-repeating. So for things such as stud walls, if you have a stud at every 16 inches, it's having it be a repeating member gives you additional capacity. The service condition is defaulted to dry. If the humidity or if the wood is treated in a different way, the service condition can be toggled to wet, and this will reduce our capacity. Temperature range as well, and whether or not it's incised, and directly consider shear deflection. So shear deflection is deflection due to shear, and we use the APA T082 reference to calculate shear deflection. And all of our other deflection things can be set here. This check bearing is actually, so it's for more for stud walls. If we consider a stud of the same member to be a bearing plate at the bottom of our studs, this is what this is checking. So a bearing check will be performed on the column, on the stud that it bears on. And so we're checking for crushing perpendicular to grain. So if it's just a column and it's not a stud wall bearing on an equivalent stud, then we can leave this checked off. And then we'll go through all the load combinations, and this is kind of all the calculations that we do. So everything from pure axial to pure bending, as well as bending, the interaction between bending and compression, as well as shear design and deflections. And all of that is summarized up here in the summary portion. So we have the critical axis load, axial load, and the allowable axial load. And this is different for X and Y direction because the stud buckles in with different capacities. And then we have the critical X-axis moment, which is the maximum moment that is being applied on the stud, as well as the allowable. So this shows that we're at 20% utilization. And then we have the combined bending and compression interaction utilization, and this is at 33%, as well as all the deflections. So it seems like we are quite over-designed in this case for a 12 feet high column, 12 feet tall column, and we can reduce the size of this column or stud. And one way to do that is just to decide if what type of column we want. So usually for studs, it would be dimensional lumber. And then we can just scroll down the list. And if you know what species you want, we can select that here and then kind of just scroll down the list until we find one that is that passes all the checks. So it seems a 3x14 will pass all the checks. Seems quite wide for a column. So maybe we want to use a 3x10 instead. And if a 1-ply 3x10 doesn't work, we can use 2 plies. And this allows you to increase the number of plies. And we assume that plies act. We assume that the plies act together. And that's all for our wood column template.